Hello and welcome to the third episode of Deconstructed. On the last episode, I added the twirl to the game, and on this episode, we're going to be focusing on adding a slide. As simple as it sounds, this ended up being more complex because of the variations. You could either have crouching in place, a running slide, or a full-on downward slope slide. While down is used to slide in the game, if you press up mid-slide, it cancels the slide, so I had to account for that. I decided to use the same key though. I also had to account for the fact that if you move in the opposite direction of the slide, it stops the slide as well. So the first thing I did was create an input for the slide. I went ahead and called this crouch because all the slides stem from the original crouch button. It just depends on how you're moving. I then added the modifier of down to the input, which means as long as it's pressed, it will take the input. So like holding it down will count it as sliding, and then letting it go will count as not sliding. I then added that to the mapping and deleted the original S key, which was used to walk. So next thing I wanted to do was add the input to my blueprint. I had to account for sliding from a walk, which I call partial slide, and sliding down a slope, which I call full slide. When sliding down a slope, you had to just press it once and press it again if you want to stop. When sliding from a walk, you had to hold it down, and once you let it go, it stopped sliding. So I made two Boolean variables, one called is crouching and one called is sliding. Is crouching needs to be held down, and is sliding only needs to be pressed once, kind of like an on and off switch. So to handle this, I set is crouching to be true whenever triggered and set it to be false when completed, which basically means as long as the crouch key is being held, Boolean will be true, and as soon as I let it go, it will be set to false. I then went ahead and set up the is sliding Boolean. I could have used the flip-flop node here, but for some reason it wasn't working when I tested it. So I just kind of manually made a flip-flop. I plugged it into the started, which only accounts for if the key is pressed once. If sliding was true, set it to false, and if it was false, set it to true. I then went to my event tick and started to create a debug to show which key was being pressed or which Boolean was activated depending on how I was pressing the key. So I did this by creating two print string nodes and changing the colors of them, setting the duration to the delta seconds of the world, and then plugging the Boolean as the string, so it'll say true when the Boolean is true and false when the Boolean is false. So you'll see when the pink is true, that means I'm holding it down, and when the blue is true, that means I just pressed it. So anytime pink is false, I let it go. Anytime blue is false, that means I pressed it again to undo the is sliding. Now it's time to create the logic for the crouching and sliding events. So the first thing I want to do is determine if the player was on a sloped surface. Now shout out to Unreal University. I did use his technique on this, or partially use his technique on this. I got the character movement component and then got the current floor. I then broke the floor result, and from that I broke the hit result. I then created a variable from the normal of the hit result. This will be used to add some velocity to the player to make them slide in the direction of the slope. I then got the dot product of the impact normal, put 0, 0, and 1 as the vector, 1 in the z-axis, and then got cosine of the angle between the two. What this basically does is return the angle of the slope the player is standing on. So I went ahead and saved that as a variable, and I'll be using that to check if the player is sliding. So as you can see, I took the absolute value of the angle to account for whenever it's a negative angle, and I checked if it was greater than 10 degrees. So if it's greater than 10 degrees, then you'll tell the game that the player is on a slope, which in turn will be used to allow the player to slide. And afterwards, it was time to organize. I then went into my folder, my blueprints folder, and added a folder called enums. This is where I will store my enumerations. So I created an enumeration called crouch mode, and basically what enumerations do, they kind of function as state machines. They tell the user what state the player is in, or it can be used for many different things really. But here I'm going to use it to tell the player what to do when the crouch button is hit. So as you can see, I'm adding my different enumerators. I have none, which means the player isn't crouching at all. Crouching, which means the player is crouching in place. Partially sliding, which means the player crouches after walking. And fully sliding, which means the player is crouching down a slope. I then went into my blueprints and I added an event, and I called it the crouch mode handler, which basically sets up the logic to tell the blueprint which state or which enumerator should be active. So I started off with a basic crouch, and what I'm doing is setting up a series of booleans to tell when the player is just crouching. So if the player is sliding and crouching, or in the case where the player is pushing the down button and the player is not moving past a certain speed or on a slope, then it would tell the game that the player is simply just crouching in place. Here I just added my enumeration to the list of variables in my blueprint. And as you can see, whenever I use the set for the variable, it shows the different enumerators inside the enumeration. And I set this to crouching, which is the mode that the player will be in. I then dragged off from the false of that branch if the player is not crouching, and started to set up a series of booleans for if the player is sliding or fully sliding. So basically what I did was check if the player was not only sliding but was on a slope. And if the player does meet those conditions, it tells the game that the player should be fully sliding. So then I dragged out another branch and started setting up my series of booleans for if the player is partially sliding. And what I basically did was check if the player was crouching and either sliding or not on a slope. If both of those conditions are met, then set the enumeration as the player is partially sliding. And if none of these conditions are met, I set the mode to none, which means the player isn't trying to crouch or slide at all. And I also set the is sliding boolean to false, just in case the player finishes sliding down a slope, but they never got the chance to hit the key to reset, it resets by itself. So what I wanted to do now was create events for each state that the player may be in. And I started by creating an event for if the player was in the none state. I called it reset crouch. And what I did was if the player was in the none mode, I would reset the is crouching variable and set that to false. Then I went to my event tick and added the crouch mode handler. I then started to create my event for when the player was in the partial slide state. So basically what I wanted to do was get the character movement and set the braking, deceleration, walking to 0 initially, which basically takes away the friction between the player and the ground. After I did this, I added a delay And then my plan was to set it back to its default value, which is 2048. But I wanted how long the player slides to depend on the velocity. So what I did was I got the velocity and I divided it by 1,000, which the velocity is in the hundreds range. So this would get it in the tenths range. So the delay would be like a tenth of a second or around that range, depending on how fast the player is walking. And then it would go back to its default friction and then the player would stop sliding. And now it's time to add the event for when the player is in the fully sliding state. Basically what I did here was just set the braking, deceleration, walking to 0. This is because I'll use a separate event to set it back to its normal value whenever the player is done sliding or fully sliding. So I wanted to make sure everything was working properly. The first thing I wanted to check was if I properly created the variable for the ground slope. So I plugged that into print string, added the duration as well delta seconds, and set it to a different color. And I was going to test out if the game properly shows the angle of the ground I was standing on. But I accidentally forgot to add the events that I created, so I went back and added the events that I had made before, and now it's time to test. As you can see, when I started, I was standing on flat ground. It was 0. And then I created a little slope, and you can see I stood on it and it showed the angle that it was. And I just kind of played around with the rotation of the slope to see if the angle adjusted with the rotation, and it did. So the next thing I wanted to test was if the enumeration was working properly. So I plugged that into the print string and then went back into the game to test it out. It's kind of hard to tell here, but things are working as intended for the most part. Whenever I was doing nothing, it was none. When I was on a slope, it was fully sliding. And when I walked, it turned to partially sliding. So next I wanted to add some velocity in the direction of the slope. To do that, I used the launch character node, and I'll be using the variable I made for the floor normal to help determine what direction the character is going to be launched. So I got the floor normal, and since floor normals are values between -1 and +1, I multiply it by a float value of 1000. That's going to determine how strong the velocity is. I then got the ground slope, divided it by 45, since that's about a half rotation. We're going from 0 to 90. Added it to 1, and then multiplied it by the floor normal, which I did multiply by 1000, but I ended up changing it to 1250. This is just what I found to be the best values for me, but honestly I might go back and play with them some to make them more like the game. If you want to replicate this, you can use values that you feel suits your desired output. I also had to negate the Z value because it would be launching the player upwards instead of downwards down the slope. So I multiplied that by -1, and then I just plugged in my X, Y, and Z values into my launch character. I then hit X, Y, and Z override to override all velocity and not just add on to. Now that I created my event for each state, I then created an event to carry out the event based on the state that the player was in. And I called this crotch relayer. Basically how it works is I plug in the crouch mode, and based on each state, I plug in each respective event. So I plugged in the reset crouch whenever the player was in the none state, and I plugged the partially sliding event into the partially sliding state, but I had to use a do once node since I was going to call the relayer on tick, and I just reset it whenever the player had been set to the none state. And then of course plug the fully sliding event into the fully slide state. I then went to my event tick and added this event. I then went ahead and organized my blueprint. Afterwards, I created an event, and the goal for this event was to make a timeline that eases the braking deceleration power from 0 to its maximum value. So basically, it slowly picks up friction with the ground as the slide stops. So to do this, I used a similar approach to how I did the twirl. I made a timeline from 0 to 1 second, and then multiplied the timeline output by the maximum value, which is 2048, and played the timeline from the beginning. I made the timeline 1 second and set that as the braking deceleration for the walking. Here I realized I have no idea how to spell deceleration, so I ended up going back and fixing my typos. I then wanted to implement this into my reset crouch event. So what I did was I went and got a branch, checked if the deceleration value was not at its maximum, and if it wasn't at its maximum, then I eased into the maximum value from wherever it was, which should be 0. I also had to include a do once node since I was using a timeline and the reset crouch event runs on tick. I didn't want the timeline to repeatedly try to play every tick, so I had to use the do once node alongside the branch to ensure that the timeline only plays whenever that condition has not been met, or when the braking value is not already maxed out. So here I just wanted to test my sliding down a slope, and as you can see it worked, but it kind of had too harsh of a velocity in the Z direction. So I ended up going back to fix that later. But for now, I had to add the slide cancel whenever you walk in the opposite direction of which you are sliding. So the way I did that was I got the velocity, but I negated it since the positive X direction would be negative X direction for me in my game because of the way I orientated the camera. But I multiplied that by the input direction value, and if it resulted in a negative number, which means one is going positive direction and one is going in negative direction, or they have opposite signs, then it would stop the sliding, which is what I want to happen because if the character is sliding forward and the player walks against the grain of the slide, it should stop the slide. So if the condition is met, I use the ease into brake that I created, which slows down and increases the friction essentially, and then I set the is sliding boolean to false. I did have one issue though. Whenever I was sliding down a ramp, I couldn't jump or twirl, so I had to go back and fix that first. As you can see though, the slide cancel was working. But to fix the twirl issue, I went into the launch character where I added velocity in the Z direction, and I just got the character's current velocity in the X and Y direction, and then plugged that into the launch character velocity. And basically what that does is preserve the momentum that the character already had sliding down the ramp and adds that into the swirl. And this is what it looked like after I fixed the issue. I then had to fix the jump issue, which I fixed similarly to how I fixed the twirl issue. The first thing I did was set the is sliding boolean value to false to ensure that the character stops trying to slide whenever the player jumps. And then I used the launch character node. I then plugged in the player's velocity into the X and Y direction, similarly to how I did with the twirl. And I entered a static value of 500 for the jump and enabled Z override. But for the X and Y override, I needed a condition because I wanted the character to behave in a regular jump if it wasn't on a slope, but if it was on a slope, then I wanted it to carry the momentum of the movement, which was a more snappier jump. As you can see, jumping up the slope, it's a lot snappier, a little bit harsher, but whenever I'm off the slope, it is a softer jump. I then went back, organized everything, and added some descriptions for some of my variables, and now it's time to try to fix the harsh falling off the edge. And initially I tried to do this by disabling the Z override for the launch character, but as you can see, that just made the fall off really soft and kind of took away all the momentum. So instead I just tried to divide the Z velocity by a value to soften it, and I started off with 4, but for some reason, I guess it was too soft, it would start to play the fall animation mid-slide, so I had to strengthen it, and I think I'll go back and fix it once I add in some sliding animations, because I don't think I'd have to suffer from that problem anymore. But this is the Z velocity I ended up going with in the end. I think it's pretty neat. It's not too strong, but it's not too weak. And I kind of just experimented with sliding down different angles of slopes. And I'll probably experiment with it a bit more in the next episode, but this episode was kind of getting long already, so I just kind of left it where it was at. So in the end, this was my final product. This is me sliding down a slope. This is me doing a partial slide, and then there's no crouching animation, so I can't show you that, but in the next episode, I will add those. Thank you guys, like and subscribe.